This program has long made a mission of exploring the plain, ordinary ingredients of everyday life. Dried pasta, steak, potatoes, salt, biscuits, peas, that sort of thing. And yet, we've never taken more than a sideways glance at the most basic and universal ingredient of them all. An ingredient that plays a role in every edible on Earth. Say hello to dihydrogen monoxide, H2O. The simple yet unfathomably significant lopsided arrangement of one oxygen and two hydrogens that we call water. Life cannot exist without it, and yet it can spread death and destruction and disease like nobody's business. It covers the great majority of our planet, and yet, as our population grows, many folks worry we may soon run out. It is as ordinary as an utterly unique chemical compound can be, and although every cooking operation there is depends upon its successful management, cookbooks rarely discuss it. Well, in this program, we'll deal with water's various journeys to our home. What happens once it's here, well, that'll have to wait for another show. Why? Because water is a mighty deep subject, not to mention if you were awake on March 30th, 1972 at 1:17 p.m. in Mrs. Baker's science class, then you probably know everything you need to know about the water cycle. If, however, like myself, you were rendered unconscious by the old girl's drone box, then listen up. It all begins with evapotranspiration. Can you say that? Good. That is the evaporation of water from oceans, lakes, and seas, as well as transpiration, which is from plants and animals like you and me, into vapor. Okay? Now, condensation is the accumulation of said moisture into clouds. Aw, they're pretty. When conditions are right, condensation turns into precipitation, some of which is absorbed into plants via interception. The rest either stacks up as snow, some of which becomes glaciers and polar ice caps, or it begins its long gravity-fueled journey back to the ocean, seas, or lakes. Some of this water travels deep underground and is called, oddly enough, groundwater. The rest moves on the surface via streams, creeks, and rivers. We call that, yeah, you got it, surface water. Decades of beer advertising have conditioned us to believe that when it comes to purity, you just can't beat a cold, fast-moving mountain stream. But the truth is, finding safe, drinkable surface water has always been something of a chore. Why? Well, because water supports every kind of microbial life there is. Protozoa, parasites, viruses, bacteria. How do they get there? Well, you see, animals come to drink the water, and when they make withdrawals, they sometimes make deposits. Hey, look, somebody threw a quarter in here. Oh. You know, folks will throw a coin into a stream or a brook like this for luck. But ancient peoples had another reason. They believed that they were buying favors or sometimes protection from a wide array of nymph sprites and water fairies who supposedly populated Of course, since surface water moves, it's a really great place to put things that you want to get rid of. For instance, you could... Look over there! It's a rare pair of Corpus corrupti. Oh my gosh, and we caught them in the middle of their ancient dumping ritual. Hey guys, how you doing? Oh, don't run away! Come on, I just want to... Oh, well, you know, large-scale industrial dumping is really pretty much a thing of the past, but surface waters like this are still vulnerable, especially to runoff, things like insecticides and fertilizers from large-scale farming. And, of course, surface waters have seasons to contend with. Hey, I want my money back! Although a great majority of surface water runs into lakes, oceans, or simply evaporates, some of it is channeled into reservoirs, like this one in Atlanta. Now, this water looks pretty good right now, but heck, any residential pool owner will tell you that it's easy to keep water clean when temperatures are low. That's pretty nice. But you know, when the mercury rises, all of a sudden the parasites, viruses, algae and whatnot come out to play and breed. Add a little bit of mud and some decomposing vegetation, and you've got yourself a potentially damaging gastronomical soup of doom, so to speak. Now, you might think that the groundwater, being underground, would be a heck of a lot safer, but there'd be monsters there too. Anyone who has ever pulled a bucket of water out of a well has tapped into groundwater contained in a geological formation called an aquifer. Now, the United States mainland sits over 11 aquifers, which contain a staggering 1 quintillion gallons of H2O. That's 1 followed by 18 zeros. How do aquifers work? Well, I'll tell you. Rainwater and runoff from mountains seep down into sand and gravel and finally pool on top of less permeable layers like clay and shale. Now, the top of this pool is called the water table, and its level changes with the weather, which is why wells that tap into it run the risk of running dry. Since pollution like fertilizers also seep into the ground, these types of wells, well, they can be less than pure. However, deep groundwater can flow between the impermeable layers and the even deeper bedrock. These confined aquifers move very, very slowly, and water drawn from them has often been underground for centuries or even millennia. Now, if you drill down into an aquifer, you've got yourself a well. If you tap into an aquifer that's under pressure, the water will come to the surface all on its own, sometimes with considerable force. That would be an artesian well. Most groundwater, however, seeps to the surface in the form of springs. We'll get back to those in a bit. Since they're protected from seepage from above and filtered by years of moving through sand and rock, waters from confined aquifers are considered to be as clear and as clean as water can get in nature, which is not to say that they are safe to drink. In fact, regardless of whether you're talking about surface water or groundwater, clean drinking water is actually pretty hard to come by. Why? Well, it all comes down to 104.45 degrees, and I don't mean temperature. Oh, and by the way, if you've got a well, the government is not going to regulate that water for you, so get it tested for safety every year. (104.45). This may be the most significant number in all of human existence because it is the angle at which one oxygen atom bonds with 2 hydrogen atoms, like this. Now, that is not, in fact, a mascot from a famous amusement park. It is a water molecule. And this particular exact arrangement means that we have a molecule that is polar in nature. That means it has a negative charge on one end and a positive charge on the other. And that means that it is essentially a molecular magnet. Just as a magnet can only pick up ferrous metals, water can only hydrogen bond with other polar molecules. There are plenty of them out in nature. Calcium, magnesium, radium, lead, dozens if not hundreds of compounds. Some of them are bad for you in any amount, but generally speaking, even the ones that are good for you can be bad if there are too many of them in there. Of course, what's really important to cooks is that hydrogen bonding means that water can act as a very powerful solvent. It can extract, say, proteins from chicken bones for making a stock, or it can extract carbohydrates from a coffee bean. And as if water wasn't already a powerful solvent all on its own, get this. When water falls from the sky as rain, it is so desperate for molecular buddies that it'll snatch carbon dioxide right out of the air. Will you be my friend? Okay, I guess. But hold it. This union forms a weak form of carbonic acid, making the water even better at dissolving things. And of course, the more CO2 we pump into the atmosphere, the more acidic our rain gets. So those little blobs, They're called flock, and forming them is usually the first step in treating surface water like this. Alum, a form of aluminum, oddly enough, is the flocking agent here, and it creates kind of these little sticky blobs that attract particulate matter in the water, as well as bacteria and other floating nasties. Now, as water moves through these sluices, the flock gets bigger and bigger and bigger, but it doesn't settle down and out until it reaches the sedimentation tanks. Here, the flock settles down to the bottom, leaving amazingly clear water. Now, before we move on, a word about disinfectants. Although there are plenty of mechanical and physical processes that can kill viruses, bacteria, and whatnot, good old chlorine is still the best and cheapest way for big systems like this to produce safe water. Chlorine is a powerful oxidant that can break down cell walls of microbial troublemakers like siege guns, pounding castle walls. And best of all, chlorine has what's called residual effectiveness, meaning that if the dose is right, it can continue killing nasties right up to the moment your water comes out of the tap. Oh, this is cool. The sediment, of course, will pile up on the bottom of these tanks and get in the way. And so these giant stirrers move very, very slowly and kind of rake all the sludge down into a big drain. Then it's taken away and used as a compost or fertilizer. Recycling. It's a good thing. In the filter house, the water percolates down through a fine carbon powder and a big fat layer of sand, which removes most of the remaining particulate matter. If you have a swimming pool with a sand or diatomaceous earth filter, same thing, just a whole lot bigger. Now, at any point during this process, the Environmental Protection Agency can swoop in and run tests in order to enforce standards on 90 chemical, microbiological, radiological, and physical contaminants. Who gives them the right? Why, the Safe Drinking Water Act of 1974, of course. shiny bright buttons. Look, shiny bright. Now, once the water has been filtered and disinfected, of course, it has to be delivered. Now, in smaller communities, that usually means pumping the water up into a large tank on top of a tower. And in that case, gravity does the actual delivering by pushing the water to the end users, that is, folks with faucets. In a big old metropolis like this, though, you got to have big pumps that are either powered by electricity or by gas turbines. Of course, sophisticated systems like this must be monitored. A room like this can watch over the water loads flowing to hundreds of thousands of customers. In the summer, when consumption is up, operators can see exactly which pumps need to be turned up and exactly where that water needs to flow. The end result? Well, America enjoys the safest, cheapest, tastiest, and most reliable tap water in the world. Still, as Dr. Malcolm put it in Jurassic Park, life will find a way, and occasionally even the best system does develop a chink in the armor. For instance, in 1999, a relatively new bug called Cryptosporidium crept through a water treatment plant in Milwaukee, Wisconsin, leaving 50 people dead, which may explain, at least in part, why millions are willing to spend billions on alternative sources of drinking water. Remember the first time you saw one of these? Well, I sure do. It was 1979, and as I quaffed the bubbly contents shipped all the way from a very famous source in France, I was certain that I was one of the hippest people on earth. Excuse me. Despite the fact that tap water costs the average American something like 1/100th of a penny a gallon, an ever-increasing number of us are spending bucks, big bucks, on bottled water. A new trend? No. Just like Shirley Bassey sings, it's all just a little bit of history repeating. From the beginning of recorded time, waters issuing from deep within the earth have been credited with possessing medicinal, if not magical, properties. Pliny the Elder, for instance, wrote of springs which supposedly could make women conceive, could change your voice, or convert black sheep into white sheep, which I suppose could be useful. Throughout the 18th and 19th century, actually right up into the 20th century, it was not at all unusual. Good morning, nurse.
Good morning, doctor.
for a respected physician, such as myself, to prescribe my client to go off sometimes hundreds of miles to visit various spas and springs in order to take the waters as a form of treatment for many a malaise, some real, some quite imagined. Good morning, Miss Mary Catherine. How are we today?
She's much improved, Dr. Brown.
Yes, no more fainting spells then?
I really do feel ever so much better.
Yes, well,
Is
tongue?
she cured?
Well, her color is improved, but I'm afraid, no, she's only mostly cured. I want you to remain here for 2 more days. I wish you to have 7 liters of water before 10 in the morning. I wish you to have a dip in the tepid pool from 11 to 12, a nap in bed from 1 to 4, another 2 liters of water before dinner, and then a dip in the chilling pool. Then you may go home.
Thank you, Dr. Brown. I feel certain that you've saved my life.
Oh, not at all, child, not at all. Well, maybe. The groovy thing is that these cures sometimes actually work. You see, as it turns out, water with a lot of iron in it is very good for treating what the doctors used to call female troubles. Sulfur waters, good for skin diseases. Carbonic waters, or carbonated waters, very good for tummy trouble. And certain alkaline mineral waters are actually good at treating gout. Speaking of, Mr. Somerset, how are we today?
Oh, doctor, the pain is simply intolerable.
Oh, that's dreadful. Well, it does appear that your condition has worsened. Let's see. I want you to go to Aix-la-Parval in Prussia. There are 3 pools there. I wish you to soak in pool number 1 in the morning, pool number 3 in the afternoon, pool number 2 before dinner, and then do the entire thing in reverse before bedtime.
Prussia?
Prussia.
How long will it take me to get there?
I'm a doctor, man, not a travel agent. Drink this along the way and call my office in the morning. Even if the substances available in the water weren't the right ones for the ailment concerned, odds are always good that the health of the patient would improve simply because the water from the springs was so much cleaner than that available in the cities. You have to remember the concept of sanitation didn't really exist before the 20th century, and in big cities like, I don't know, Paris, it wasn't unusual for wells to be dug right next to open cesspools. So in big cities, up till the 20th century, everybody stayed sick all the time to some degree or another. And that is why in places like London, beer made from boiled water and preserved to some degree with hops became the beverage of choice, even in schools and hospitals. Although the rich could afford to come hang out at springs and spas for weeks, it didn't take long for the owners of said springs to get the idea of bottling the waters for distribution. By the 1880s, you could walk into a good store in just about any city in the world and buy water from all of the best spas and springs in the world. New York, France, Italy, you name it. But they were not cheap. In fact, it wasn't unusual for the prices of spa waters to be commensurate with fine perfumes. And what's funny is that the burgeoning middle class, who couldn't afford to travel and couldn't take off the time for travel, were willing to cough up relatively big bucks for these waters because of their potential health virtues. And thus, the bottled water industry boomed, especially for thank you, the spring owners themselves, and of course, the wily physicians who endorse their wares. Thank you, sir. But this is nothing compared to the money that the bottles bring in today. We don't have a whole lot of time left here, but there are some things that everybody needs to know about bottled water. Okay, you have to understand that unlike tap water, which is regulated by the Environmental Protection Agency, bottled water falls under the watchful eye of the Food and Drug Administration, which is required to uphold the standards set for tap water by the Environmental Protection Agency. Although state governments may adopt higher standards, although there have been no incidents of foodborne illness attributed to bottled water, there is no reason to assume that it is safer than what is supplied by your municipality. Okay, labels. If it says spring water, it must have been harvested from an underground aquifer from which water naturally flows to the surface at a specific location. Well water means that the water's been pumped out of a hole in the ground, drilled by man, right? Now, if it says artesian or artisanal water, then that hole in the ground hit an aquifer that was under pressure, so the water comes up to the surface under its own, sometimes like a big gusher. Now, if it says a naturally sparkling, that means that the water had dissolved CO2 in it, enough to be nice and bubbly bubbly when it comes to the surface, but it can't be added. If the water has more than 250 parts per million of total dissolved solids, that means minerals, then you can label the water mineral water. Most of your expensive European imports are mineral waters, and they have a very distinct flavor that some Americans like and some Americans don't. Now, here's the potentially surprising part. About 30% of the bottles behind me, including the top national brands, harvested from municipal sources. Tap water. Hey, America. Before you pop the cap on your next dose of artesian well, glacial runoff, spring bubbly water, or whatever, think about the bottle. This bottle and about 50 gajillion others just like it is made from polytetrafluoroethylene, or PET, which was developed by two British chemists and patented in 1973. PET is strong. PET is light, PET is stable, chemically speaking, and PET is clear, which is good for Americans because we like to see what we're buying, especially when we're, paying $3 for a bottle of water. Best of all, though, PET is completely recyclable. Okay, run this little buddy through the chipper, and you've got yourself the makings of some very nice wall-to-wall carpeting. But my fellow Americans, there is a catch. Despite what many of you have apparently been led to believe, PET bottles are incapable of rolling themselves to the recycling center, okay? Right now, forests, beaches, landfills, roadways, automobile back seats, and neighborhoods just like yours and mine are starting to look a lot like this. See you next time on Good Eats.